Hi, today we're going to be taking a look at FinalScratch, which was the very first digital vinyl simulator, or DVS, on the market. It was released in 2002 and was enormously instrumental in kickstarting the transition towards digital DJing, which now dominates the industry. And what's more, the software for it initially ran exclusively on Linux, meaning many DJs were using the open source operating system long before the general public had even heard the name Linux. Over the last couple of years, I've been researching the history of FinalScratch, tracking down hardware and software, and even contacting the original developers, so I'm delighted to be able to finally share this video that will hopefully cover most of the aspects of this monumentally important piece of DJ and Linux history. Anyway, let's get started. For the non-DJs in my audience, digital vinyl simulators allow DJs to mix and scratch digital audio exactly like they did previously with vinyl records, using exactly the same equipment. Let me briefly explain. If you're a regular analog vinyl DJ, your setup looks like this. You have two turntables that you connect to a mixer, which then connects to a sound system. You play vinyl records on the turntables and mix between them using the mixer. Couldn't be simpler. For a DVS system, the setup is nearly identical, except there's a little box connected between the turntables and the mixer. The box then connects to a computer, which stores your digital audio collection in MP3 format or whatever. Then, instead of playing normal vinyl records with music on them, you play records that have a special digital timecode recorded on them. The computer can use this timecode to determine exactly how fast and in what direction the record is playing. It then plays the digital audio at the same speed and direction back out through the box and sends that to the mixer as normal analog audio. This might all sound a bit convoluted, but the experience of DJing with a properly tuned DVS system is pretty much indistinguishable from the real thing. Even turntablists, i.e. scratch DJs, have pretty much universally adopted DVS systems, and they are allowed in the vast majority of DJ battles and competitions. These days, the DVS box itself is usually integrated into the mixer, and there are even turntables like the Rain 12 that can only be used for DVS, as they have no tone arm and thus can't play normal records at all. Anyway, that's it for the DJ history lesson. Let's go into the history of FinalScratch itself. It's the brainchild of a very clever human called Mark-Jan Bastian, an electronics engineer and software developer who was based in the Netherlands at the time. I actually met Mark-Jan a few weeks ago at the EMF Camp Hacking Festival in Herefordshire, where we had a long and interesting chat about DVS technology and many other topics. He was kind enough to bring his irreplaceable FinalScratch prototypes and patent documents to show me, and even gave me a set of FinalScratch slip mats that now hang proudly on my workshop wall. The original version was developed in 1998 for a fairly obscure operating system called BeOS, which was designed for digital media work and so was chosen for its excellent low-latency audio handling capabilities. Mark-Jan had the very first timecode record cut at a Rotterdam-based lacquer cutting shop, then once that had been tested, went on to get a limited run of 250 records pressed at the record industry plant in Haarlem, Netherlands, which is still going strong to this day. Later on, Mark-Jan joined Intuit, an Amsterdam-based tech company, where he continued to develop FinalScratch into a product, and was charged with developing FinalScratch's digital electronics, USB driver, and music playback code. He was aided by Bill Squire, who designed the analog electronics, and Tim Hemel, who handled the user interface and timecode. Testing was conducted by DJs such as Richie Houghton and John Acquaviva, who famously demonstrated it to an astonished-looking Carl Cox in this video from around 2001. After extensive development and testing, FinalScratch 1.0 was finally released in autumn 2002 in conjunction with Stanton Magnetics. By this time, BeOS had been discontinued, so N2IT developed their own version of Linux to run the software, as Windows and macOS weren't quite up to the task of running low-latency audio at the time. FinalScratch certainly caught the attention of the entertainment industry. Contemporary reviews were stunned at how innovative it was and how well it performed, and many DJs quickly realised the limitless potential of being able to play any sound imaginable without having to press it up to vinyl first. There is more FinalScratch history to talk about, but we'll leave that for later on in the video. For now, let's start playing with FinalScratch 1.0. The FinalScratch package contains the FinalScratch hardware itself, or as they call it, the Scratch amp, as well as a CD containing the Linux-based software, a couple of timecode records, and various instruction manuals. I also managed to buy a collection of spare timecode records from someone on eBay for the princely sum of £11.94. Both me and the seller probably felt like we got a good deal, as I can't imagine anyone else on the face of the planet actually wants FinalScratch records in 2022. There were a few different pressings of Final Scratch records with various different labels, sleeves and track layouts, but they can be broadly grouped into two types: standard and scratch. The standard record is pressed from 180-gram vinyl, which is great for quality and durability, but when it comes to scratching it's far too heavy to be able to manipulate properly. So later on, Stanton released a special scratch record designed specifically for the needs of scratch DJs, coming in at a relatively lightweight 125 grams. One side has 3 separate sections of timecode. I'm not exactly sure what the rationale for this was, but personally I found it useful to use the inner sections as they are much less prone to skipping when scratching, as any DJ knows only too well. Even weirder, the very innermost section is broken up into 30-second segments, apparently for quick needle dropping during scratching and battling, but given the choice I think I'd prefer to use the much wider 1-minute segments on the other side of the record for needle dropping purposes. Anyway, let's get this thing set up. The first problem with testing software and hardware this old is finding a suitable PC to run it on. I'm a bit of a computer hoarder, but when I started researching this video, all my computers were either too old or too new to be able to run Final Scratch. Regular viewers of my channel, however, will know that I recently built a computer precisely for situations like this. I call it the Retro Rocket. Check below to a link to the video where I built it. The rest of the setup is pretty straightforward. I'm using my Vestax PDX 3000 turntables and PMC07 Pro mixer, which would have been a fairly common setup at the time Final Scratch came out, although the turntables are a newer revision. I connected them to the Scratch amp as per the instruction manual, then connected the Scratch amp to my Retro Rocket. Now, despite being Linux-based, Final Scratch 1.0 actually requires a copy of Windows to be installed. The current version of Windows at the time would have been Windows XP, so I installed that for what must have been the 50th time this year. I do a lot of playing with old versions of Windows. Final Scratch didn't like XP Service Pack 3, so I had to find a copy of Service Pack 1, but once that was sorted, I was able to progress to install Final Scratch. The instruction manual just says to boot the computer with the CD and the drive, and doing this brings up the boot screen for FinalScratch 1.0? After that, a menu appears which will look very familiar to Linux fans, being based on the dialog utility. After glossing over the license agreement, it rather audaciously demands to convert the Windows partition from NTFS to FAT32. But unfortunately, Linux didn't really have a proper NTFS driver at the time, so Final Scratch basically had no choice. Once finished, it ejects the install disk and reboots the computer. Now, instead of the Windows XP boot screen, we get this lovely graphical boot menu that lets you select between Windows and Final Scratch. The background appears to be a still from that Carl Cox video I showed earlier. On startup, the file system checker notes that the root file system hasn't been checked in over 7,000 days, which is nearly 20 years. The timescale certainly checks out. Then, after a slightly heart-stopping corrupted screen, it brings up a full graphical user interface. Linux fans will recognize this as the Window Maker desktop. The main purpose of this desktop is to allow you to launch one of 2 applications at the top left. The bottom one is called Record Boxer, and it's where you import audio files and organize your music collection into playlists. The top one is the Final Scratch application itself. If you've used any recent DJ software, you'll probably be astonished at how streamlined the Final Scratch interface is. Instead of there being hundreds of buttons, there are like 6. But this is by no means a bad thing. Remember, the idea behind DVS is that you still did all your audio manipulation on turntables and a mixer, so the only time you ever needed to look at the computer was to load a new track. Keeping the interface simple and clear is therefore very important. Although some of the interface can be used with a mouse, Final Scratch is really intended to be operated by keyboard. But it really couldn't be simpler. You pick a song using the arrow keys, then hit Ctrl F1 or F6 to load it into the left or right deck respectively. Then fire up your turntables, drop the needle on the record, and you're away. And as you can see, the system still works perfectly after 20 years. Mixing, scratching and beat juggling feel and sound absolutely great, and honestly I'd struggle to tell the difference between this and a modern DVS system, or even real vinyl. I mean, sure, it's missing practically all the features of a modern DVS like cue points, loops, time stretching, effects, etc. But that's also true of real vinyl, so for DJs back then that was no problem. I'd certainly be perfectly happy using this for gigs even today. There are a couple of minor problems. Final Scratch doesn't seem to make the track go quieter when you move the record slower, unlike how a real record works. This means that you get weird distortion when doing slow scratches. But these are tiny details and really don't matter for the vast majority of the time. Anyway, I know you didn't click on this video just to watch me scratch, so let's do some tinkering under the hood of this weird Linux distro. If you right-click the desktop, you get a menu with a very tantalizing option called Maintenance Shell. This brings up a terminal window with a standard Linux shell running as the root user, which is like administrator on Windows. This lets us have a poke around the file system to see what's installed. Firstly, we can check the issue file to see what version of Linux this is based on. Turns out it's Debian 2.2, which is actually the exact version of Linux that 18-year-old me was using on my home server in 2002. Looking at the installed packages, it looks like it comes with a very minimal set of programs, so not much interesting really, although the xutils package is installed, so we do get some desktop toys, including the iconic Xeyes program that was seen in every Linux magazine screenshot back in the day. So not much to see here really. If anybody has interesting they want me to try with this weird version of Linux, then please get in touch. And no, I'm not going to try running Doom on it. To do that, I'd have to statically compile a Doom Oh fine, here's Doom running on it. Are you happy now? The next thing I want to do is take some latency measurements. One of the most crucial attributes of a DVS system is how long it takes to respond to DJs manipulating the record. If the latency is too high, it will feel very unnatural and make it difficult to perform a lot of scratches. To test the latency of a DVS system, all you have to do is play some timecode into it and measure how long it takes to respond. On this computer, FinalScratch 1.0 has an 18 millisecond latency. By way of comparison, the DVS I currently use, Traktor Control Z2, was released 10 years after FinalScratch and gives a latency of 22 milliseconds on my brand new Windows 10 laptop. I mean, the Z2 is getting pretty old too, but people have used it to win DMC and Red Bull DJ competitions, so the fact that the FinalScratch actually beats it despite being a decade older is really, really impressive. Now we've covered the system itself, let's take a deep dive into the hardware. The place to start is probably with the records. We've already talked about the different pressings of the FinalScratch timecode, but we haven't covered how the timecode actually works. It's all based around a concept called Quadrature Encoding, which is a very commonly used method of determining the speed and direction of a moving object. Basically, it works like this. Imagine you're sitting in a room with a tall, narrow window, watching a convoy of equally spaced buses go past on the road outside. If you know how long each bus is, you can tell exactly how fast the convoy is going by watching how quickly they appear and disappear in the window. This is great for determining the speed, but how do we get direction? Well, we can add a second window that's exactly 1/4 of the distance between each bus away from the first window. Now, if the buses are going rightwards, each bus will appear in the left window first, then the right window, then disappear from the left window, then disappear from the right window. Likewise, if buses are going leftwards, they will appear in the right window, then the left, then disappear from the right, then disappear from the left. Now we can tell both the speed and direction of the convoy of buses to a high degree of accuracy. This is exactly how DVS timecode works, except that instead of buses we have sine waves, and instead of windows we have the left and right channels of a turntable stylus. The sine waves are pressed up to the record exactly 1/4 wave delayed from each other, and by watching them cross the middle point of the waveform we can tell exactly how fast and in what direction the record is playing. Pretty neat, huh? But this only tells us about how the record is moving if we already know its starting position. How does FinalScratch determine the track position if we drop the needle in a new place? Well, there's a digital position code embedded into the sine wave itself. Let's take a look at the waveform. As you can see, some peaks of the waveform are higher than others. If the peak is small, that encodes a binary 0. If the peak is big, it's a binary 1. The binary digits make up a position code that enables the absolute position to be determined within about 10 milliseconds of dropping the needle on the record. Now you might be wondering, why bother having the relative quadrature code if we can just encode the absolute position? Well, unfortunately, the absolute coding just doesn't have the resolution required for DJing. A position code every 10 milliseconds is only 180 positions per record revolution, which isn't really enough. The quadrature code gives us over 4,000 positions per revolution, which is more than enough for the most demanding turntablists. So, now we know how the records work, let's look at the Scratch amp. It really is an attractively designed piece of hardware, completely circular with all the ports to connect it to your turntables and mixer on the top for easy access. Along the side are the other ports, a USB Type-B for computer connection, a barrel-style jack for external power, and even a USB Type-A port to allow you to connect additional USB devices, which is a really nice touch. Opening the device is simply a case of removing the 3 rubber feet from the bottom and unscrewing the screws underneath them. Inside is a lovely circular circuit board that's been clearly laid out and sports a design date of 2002. As far as I can tell, the signal flow goes like this. These are the RCA phono inputs, which are amplified and presumably RIAA corrected by this Max 414 op amp, then fed into these two Philips UDA 1325 USB codecs. These codecs are interesting devices. As well as having audio and USB support, they also have a built-in microcontroller to allow the devices to be customized exactly to the specification required. The code for these microcontrollers is stored in these two I2C flash chip. I pulled them off and read them in my ROM programmer, but I don't know what I expected to see really, just some device name strings. Anyway, the two Philips USB codecs are connected to this WinBond W81181 USB hub chip, which allows the two codecs to be plugged into one USB port on the host computer, along with whatever you have plugged into the Scratch Amp's external USB port. According to Mark-Jan Bastian, significant effort was put into keeping the three USB devices synchronized to the exact same clock signal, so that low latency could be obtained from a standard PC USB port. This is quite an achievement, especially as this was a time before low latency audio was really possible on standard PCs over USB. The final piece of the signal flow is the line outputs, which are buffered by this TL074 op-amp and sent to the RCA connectors here. Clearly a lot of thought went into the design and manufacture of this product, and it overall feels sturdy and was known to be very reliable. Hell, I have two of the things and they both work perfectly after 20 years. In 2003, Stanton decided to replace the original software with a cut-down version of Traktor DJ Studio, which was a competing DJ application developed by Berlin-based company Native Instruments. This was released as FinalScratch 1.1, which was available as a paid upgrade. I managed to find a sealed copy of it on eBay for $5. Unfortunately, the dude wanted like $60 for shipping to the UK, so instead I got it shipped to my good friend John Bees, who very kindly agreed to film this B-roll footage and just send me the disc. Thanks mate, I'll give you a link to his channel below. FinalScratch 1.1 is also based on Linux, which I thought was especially weird as Traktor was only ever officially released for Windows and macOS, but we'll go into that a little bit later. Just like before, installing 1.1 involves booting the computer with the CD in the drive, but this time, instead of installing onto the Windows partition, it creates a new partition and installs onto that. This means you first have to shrink your Windows partition to make space. This is a more traditional way to install Linux, and will probably allow better performance, but means you have to permanently lose some of your Windows hard drive space. To migrate your track collection, FinalScratch 1.1 includes one final update to FinalScratch 1.0 that converts your collection into the Traktor NML format, which is actually still used in current versions of Traktor. Note that 1.1 doesn't actually replace 1.0, you can still easily boot back into 1.0 anytime you like. This is a nice touch, as according to an unsourced claim on the FinalScratch Wikipedia page, later versions of FinalScratch didn't perform as well as 1.0, but we'll be putting that to the test later. Once installed, it starts up Traktor FinalScratch immediately. There is no traditional desktop to speak of. Everything is done inside the Traktor interface. The user interface is a lot more polished than FinalScratch 1.0, but there aren't really any new features to speak of. Most of the extra settings relate to library management, which is now done in Traktor directly rather than being relegated to a separate app. But overall, there aren't many improvements over version 1.0. I'm told that it supported a wider range of hardware than the original, but I can't verify that. At least on my PC, I still had to force VESA mode to get the graphics card working properly. There are a fair few rough edges too. For example, the About dialog has links you can click to take you to various websites for support and whatnot, but as this version of Linux has no web browser, or even any network support whatsoever as far as I can tell, the links don't work. I have a theory about why this is the case, but I'll discuss that later. Performance-wise, 1.1 doesn't feel as responsive as 1.0, and there are a few major problems. Backspinning sounds absolutely awful, and afterwards it will often play the audio at the wrong speed for a few seconds. This makes beat juggling on it pretty much impossible. I think this is because of the unidirectional timecode, but instead of skipping instantly to the correct place like 1.0 does, it instead slightly speeds up or slows down the record until it gets to the right place. It's probably fine if you're just mixing, but for turntablists, 1.1 is completely unusable. The latency measurements for 1.1 came out at around 23 milliseconds, which isn't the end of the world, but it's still a damn sight more than the 18 we were getting out of 1.0. So between that and the backspin problems, I suppose we can finally add a citation to that Wikipedia article. Now let's do some digging into this version of Linux. It's a lot more locked down than version 1.0. There isn't any official way to get into a maintenance shell. I do have a few tricks up my sleeve, however. Linux typically comes configured with a number of virtual consoles, and the shortcut Ctrl-Alt-F1 brings up the first one. Now we're greeted with a standard Linux login prompt. We probably want to log in as the root user, but what's the password? Well, a little tip for any system administrators watching, don't include your root password as part of the login prompt. That's right, the password is just NI. Believe it or not, I actually guessed on the first try. In comparison to FS 1.0, this is a much more stripped down version of Linux. In fact, it doesn't even have the PS command, so we can't easily view what processes are running. But Linux is a Unix derivative, so everything is a file. All we have to do is go into the proc directory and start poking around to see what's running. And here we can see the Traktor process command line, but what's this? The command line begins with wine. Now, Wine is an application that lets Windows programs run on Linux, sort of a bit like a Windows emulator. This means that Traktor FS 1.1 is a Windows program, just running through a compatibility layer on Linux. Very, very weird. I suspect what's going on here is that Traktor FS 1.1 was originally intended to run on Windows, but they had issues getting Windows Scratch Amp drivers running, so at the last minute they decided to run it on Linux instead. This would explain why there are non-working links in the About screen, as if it was being run on Windows there would likely always be a web browser and internet connection installed. Anyway, despite that fascinating little quirk, there isn't much more to say about FS 1.1. The user experience is slightly better, the performance is slightly worse, and it uses a weird trick to get Windows Traktor working on Linux. Fun, fun, fun. The final version of the software that was released for the original Scratch amp was FinalScratch 1.5, released in 2004. By this time, Stanton and Native Instruments had clearly resolved the issues with Windows compatibility, and so they ditched Linux entirely for this version. Installing it is pretty much the same as any other Windows software, but I had a major problem when trying to start it for the first time. You see, my copy of Traktor FS 1.5 comes with an upgrade serial number that requires online activation, but Native Instruments shut down their activation servers in 2020. I wasn't going to let a little copy protection get in my way, however, so I fired up good old Ollie debug and set about developing a crack. Now, I'm not going to go into detail about exactly how I did this, because I don't want to encourage software piracy. I'm sure Native Instruments couldn't care less about 20-year-old software that only runs on 20-year-old hardware, but it's better to be safe than sorry. I'm certainly not going to distribute the cracked version, and I deleted it once I was done with testing. But in any case, cracking it was pretty trivial. Now it will accept any serial I type in. Once that was done, I fired it up and had a play. As you can see, it's nearly identical to version 1.1 with one major addition, key correct. This allows you to alter the speed of the track without altering the pitch of the music, which is extremely useful when mixing harmonically. The key correct sounds okay for software this old, but certainly not as good as you get in modern software. Thankfully, however, Native Instruments had mostly fixed the weird backspin bug that was present in version 1.1, so beat juggling feels absolutely fine again, and honestly I think 1.5 is almost as good as 1.0 in terms of overall responsiveness. Another new feature is the ability to adjust latency between three settings. Testing the lowest setting gives about 25 milliseconds, which is 2 milliseconds higher than 1.1 and quite a bit more than the 18 milliseconds we were getting in version 1.0. Again, not the end of the world, but it is interesting seeing the difference that running on Windows gives with identical hardware. Now, although this was the final version of the software that ran with the original hardware, this wasn't the end for the FinalScratch brand. In late 2004, Stanton went on to release FinalScratch 2, which used FireWire instead of USB, and was compatible with the standard version of Traktor DJ Studio instead of requiring a special FinalScratch version. Apparently the latency was significantly reduced by switching to FireWire, but I don't have a FinalScratch 2 interface to test this with, or indeed a computer with a FireWire port, so testing that will have to wait for another day. What I do have, however, is a competitor's product that was released around the same time as FinalScratch 2 and went on to become the de facto industry standard DVS system. I speak of course of Serato Scratch Live, which was the first DVS system I personally saw being used in local clubs. Scratch Live works over USB, so I was able to test it on the exact same computer as I'd been testing FinalScratch on. Scratch Live had a reputation for being able to achieve single-digit millisecond latency, but I didn't really think it would manage it on this mongrel of a PC. But fair play to it, I was able to get a truly astonishing 7 milliseconds with no dropouts or other problems. That really is incredible, and shows that moving to a FireWire interface was probably unnecessary for FinalScratch 2. Although to be fair to Stanton, FS2 has a lot more inputs and outputs than Scratch Live, so maybe they needed the extra bandwidth FireWire provided. In any case, FinalScratch 2 wasn't long for this world. Stanton and Native Instruments had a bit of a falling out in 2006, and FinalScratch support was removed permanently from Traktor. In response, Stanton re-released the FinalScratch 2 hardware as FinalScratch Open, which was designed to be used with other companies' DJ software such as Mix Vibes or Decadance. Unfortunately, it never really took off as a product and ended up being discontinued fairly soon after that. Native Instruments ended up releasing their own DVS system called Traktor Scratch, which went on to do extremely well in the market and formed an effective duopoly with Serato Scratch Live for over a decade. But both Serato and Traktor owe their success to FinalScratch for pioneering the concept of digital vinyl. Who knows what the DJ scene would look like today if it hadn't been for the efforts of Mark-Jan Bastian, Squire and Tim Hemel over 2 decades ago. Well, that's about it for this Final Scratch video. I'd like to say thanks again to Mark-Jan Bastian for developing this groundbreaking product and kindly answering my slightly drunken questions about it at EMF Camp. I'd also like to thank John Bees for helping me track down FinalScratch 1.1, all my followers on Instagram for helping me find FinalScratch 1.5, and Mark Settle from WorksLab for letting me use screenshots of his old website. If you liked this video, then give it a thumbs up or leave a comment, and if you want more videos about retro technology and DJ equipment, then consider subscribing to my channel. I'm hoping to take a look at Serato Scratch Live and possibly FinalScratch 2 in a future video. Thanks for watching, and catch you next time!